So Euclid, Euclid 2022 8a, I found a way that you can use the Shoelace formula for this that simplifies the problem a little bit, and it's kind of a great introduction on what the Shoelace formula is. So let's get started. So suppose a is greater than 1 over 2 and that the parabola with the equation y is equal to ax squared plus 2 has vertex v. The parabola intersects the line with the equation y equals negative x plus 4a at points b and c as shown. If the area of the triangle VBC has 72 over 5, determine the value of a. So this, let's see, so this triangle over here is 72 over 72 over 5. Okay, so the first step is what information do we have? So this is plus 2 on the parabola, and then by the graph we can kind of know that the coordinates for the vertex would be 0 and 2, right? And the parabola intersects the line with equations. So this is the line over here, and we want to find points b and c. So what we can do is just make them equal to each other. So ax squared plus 2, that's the equation of parabola, negative x plus 4a, right? And bring all this to the other side. Plus x plus 2 minus 4a. Sorry, I'm writing on a mouse, so it's kind of inconvenient, but that's fine. So then you're like, okay, how do you solve for x, right? How do you solve for coordinates? Well, you just treat this as a normal quadratic formula. So ax, I should probably, Jesus, sorry about that. Let me see here, select here. Okay, right. So I have my quadratic formula, right? Negative, everyone knows how to do quadratics, so just x equals negative 1 plus minus root 1 squared minus, well, it's, 4a, that's your c, and then that's your a, and then your c is this thing. So 2 minus 4a, right, over 2a, which is actually just 2a. And then you simplify this, you get negative 1 plus minus square root of 16a squared minus 8a plus 1. Alright, over 2a. And this is a perfect trinomial, so you can put this as negative 1 plus minus, this is 4a minus 1 squared. And then you can just cancel this square root with this. If you see this, you know you're on the right track, because it's kind of too much of a coincidence, alright, for this to work. So negative 1 plus minus 4a minus 1 over 2a. So those are your points for b and c. Alright. So let's see. So let's just bring this over here. So let's say, okay, wait, let's just go for negative 1 plus 4a minus 1 over 2a would simplify to 4a minus 2 over 2a, which is just 2 minus 1 over a, right, if you simplify it. And if it's negative, and then let's see, I have this line here, negative 1 minus 4a minus 1, you get over 2a, you get -2. Okay, so this is your first x coordinate, this is your second x coordinate, and if you come over here, b is to the left, so let's just say b. Oops, let's just say b. You know your x coordinate now. Let's say this is the -2, and you don't know your y. Your c, this is your coordinate 2 minus 1 over a, and then this is you don't know your y, right? So we should probably make another page here. All right. So you don't know your y, but you know your x's already. So you can just plug them in this equation. -x plus 4y, right? Y equals -x plus 4a. So your b is -2. Yeah, sorry. This is just so ugly, and I can't stand it, but whatever. So y would be -2 plus 4a, whatever. So y is 4a plus 2, right? And for your c, it's -2 minus 1 over a plus 4a. So your y is -2 plus 1 over a plus 4a. Okay, so that's your y for c, and this is your y for b. So now we know we can just write this in 4a plus 2. This is too small, not enough space. 2 plus 1 over a plus 4a. Sorry, this is a -2. Yeah, -2. So now you know your coordinates for b and c, right? And you know your coordinates for v. So how do you calculate this triangle? Now, the official Waterloo solution makes you calculate this. Sorry, makes you calculate what the. So it makes you calculate this area. Let me see. Yeah, it makes you calculate this area. So another point that's parallel to v, that's in the same line as v, and they make you calculate this 1, 2, 3, 4. Yeah, this polygon first, and then you subtract the triangles. But there is an easier way to do this that just calculates so now you can use the Shoelace formula to calculate the area of the triangle BCV. So when do you use the Shoelace formula? Whenever you have coordinates, all three coordinates on a plane, you can use the Shoelace formula. All right, so this is essentially how it works. Don't be too intimidated by this notation. So I'll show you how you use it. So you use 1 over 2, and then you have all your coordinates, right? You place your first coordinate in a counterclockwise position. Sorry. Yeah, in a counterclockwise position. So let's say you have B first, and then V, and then C, and then go back to B. Okay, so you place them like this. Your X is on top, and Y is at the bottom. Okay, so B is -2, 4a plus 2. Your V is 0, 2 minus, this is your C, -2 plus 1 over a plus 4a. And then you have to go back to B. Alright, you have to go back to B. That's really important. And then you put this in kind of like a matrix. Yeah, and then basically how this works is you multiply everything here. Let me just put this in a different color. You multiply everything like this. Oh, I'm not doing this really clearly, but here, like this. Okay, this is all right, and then you plus, you add them up together, and then you multiply everything over here, but then you subtract them. Okay, you subtract them. So that's basically how it works. So then you have to actually calculate now with some painful algebra. So for example, -2 times 2, -4, plus 0, right? This is just 0. And then this times this, you have to simplify it. This becomes 8a minus 2 over a. Okay, and then you're minus. So this is 0, whatever, we don't care. This 2 times 2 minus 1 over a. 2, that's just 4 minus 2 over a. And then this times this is 4 minus 2a minus 8a, right? So, and then you have another bracket over here. So this is how the Shoelace formula is set up. And you gotta simplify. Just simplify. I'm gonna skip some steps over here, but okay, 1 over 2, -12 plus 16a plus 2 over a. Okay, and now essentially you have the area in terms of a, but you know the area. The area is 72 over 5. So you have to set this equal to 72 over 5 and solve for a, right? Because the question is asking for a. So let me just make another page here. Jesus, that's so small. What? Don't see. Okay. So let me just copy this rectangle. Oop. Alright, whatever. You get the idea. Okay. So now just some algebra to solve for a. Simplify this, you get 6. I'm gonna skip some steps. 16 squared minus 2 over 4 a over 5. 204a over 5. Jesus, 204a over 5 plus 2 is equal to 0, right? Just if you simplify this, and then you quadratics on it, and you should get a is equal to 5 over 2 or 1 over 20, right? Quadratics give you two answers, but since we have the initial condition here that a is greater than 1 over 2, then the answer must be 5 over 2. So that was Euclid 8a using the Shoelace formula. You just kind of skip through some steps here, and yeah, the answer is 8a. Sorry, is 5 over 2.